Hi, welcome back to AP Calculus. This is Unit 5. It's all about applications of the derivative. And today we are in Lesson 6, which I'm simply titling More on the First and Second Derivatives. So I really want to explore some more different kinds of problems that we might encounter and different ways to think about the first and second derivative. So for example 6.1, let's find the intervals where f is increasing and decreasing, and we'll identify all relative extrema and sketch the function. So what makes this problem interesting is that it's a piecewise defined function. So first, let's take the derivative. F prime of x is equal to the derivative of the top is 2, and the derivative of the bottom is 2x. Now, one of the questions we have to ask ourselves, though, is this still going to be x less than or equal to negative 1? Well, it's definitely true for x less than negative 1. It's definitely true for x greater than negative 1. But remember, the derivative is a limit. So it has to be approaching the same value from the left and the right. So if we look at x equals negative 1, as x approaches negative 1 from the left, we'd be looking at this top branch. The slope is 2. But if we approach negative 1 from the right using this bottom branch, we'd have to plug in negative 1 and get negative 2. So they're not the same. So we're going to have to say that f prime of 1 it does not exist. Okay, it's undefined, right? So that is an important value for us because it's going to be a critical number. Well, another critical number is x equals 0 because it makes x equals 0 makes f prime 0. We would use the bottom branch, and you can see that 2x is equal to 0 at 0. So let's use a number line to identify intervals of increasing and decreasing behavior. So I'll start at 0 and 1. All right, well, if I'm less than 0, I'm sorry, I did that completely wrong. My critical number is not 1, it's negative 1. Sorry about that. Negative 1 and 0. So if I choose a number to the left of negative 1, we'll see here like negative 3, I would use this top equation here, which is always 2. So that's positive. If I choose a value between negative 1 and 0, then I would be using this bottom equation. And you can see that for a bottom equation, plugging in any negative number would give me a negative value. Then after 0, like 1, we're back to positive again. So we can see that f is increasing on the interval from negative infinity to negative 1, and from 0 to infinity. And the only justification we give for increasing and decreasing is that f prime is positive or negative, because f prime of x is positive there. Likewise, we can say that f is decreasing on negative 1 to 0, because f prime of x is negative there. Okay? So what about relative extrema? Well, I think we can just use the first derivative test. Remember, we have an option to use the first derivative test or the second derivative test, but I've already got a number line. Let's use the first derivative test, okay? So I'm just going to state that, well, kind of don't have a lot of room here, but I'll put it here. So, we're going to say by the first derivative test. All right, since f is continuous and differentiable on this interval from, let's say, negative infinity to, I'll say 0, except at x equals negative 1. It's not differentiable there, but it's okay. I'm allowed to be not differentiable at one place. And f prime changes from positive to negative, then I know that negative 1 comma f of negative 1, which would be negative 1, is a relative max. And I need a little bit more room here, so I'm going to, it's hard to write super small sometimes. So I'm just going to put that over here. And then also by the first derivative test, I know that since let's see here, since f is continuous and differentiable on -1 to infinity, now I got an open interval around 0, and f prime changes from negative to positive at x equals 0. I know that 0, comma, for 0 I would use -2, is a relative minimum. Well, let's plot it. We're going to draw a sketch, weren't we? 1, 2, 3. Let's do 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, so we know that we have a relative maximum at -1, -1. We have a relative minimum at 0, -2. So it's going to look something kind of like that. Oh, I went too far, didn't I? That's -2. So it's going to look something kind of like that. And the other value is going to be increasing, right? With a constant slope of 2. So there's your relative max, there's your relative min. So that's how you handle a piecewise function. All right, let's take a look at another example. Given that f prime is less than 0 on the interval from -∞ to -3, and that f prime is greater than 0 on the interval from -3 to 2, f double prime is less than 0 on 2 to infinity. Okay. So what if g of x equals 2 times f of x? Is g of x increasing or decreasing at x equals -1? Well, let's see here. I feel like we could just take the derivative here. So let's do that. G prime of x is equal to the derivative of 2f of x is just 2f prime of x. The 2 just comes along for the ride as a constant. So let's take a look at what g prime of -1 would be. Well, it would be 2 times f prime of -1. Well, looking at our intervals here, we can see that on that interval from -3 to 2, f prime is positive. So that's positive times a positive, so it's got to be positive. So g is increasing at x equals -1 because g prime of -1 is greater than 0. If g of x equals f of 3x minus 5, is g increasing or decreasing? Well, let's find out. G prime of x, let's take the derivative, would be f of f prime. We got to do a chain rule, so derivative of the outside, leave the inside the same, times the derivative of the inside, which is just a 3. So g prime of -1 would be f prime of -8, right? -8 times 3. Well, f prime of -8. From -∞ to -3, we're negative. And then a negative times a positive is a negative. So we're going to say that g prime, in this case, for this g, that is, g prime of -1 is less than 0. So g is decreasing at x equals -1. Well, what if g of x equals f of the natural log of -x? Well, again, let's take the derivative. G prime of x is equal to f prime of, leave the inside the same, multiply by the chain, which is u prime over u. So what would g prime of -1 be? It would be f prime of the natural log of -1 times a -1 over -1. Well, the natural log of, negative of -1, which is a positive 1. The natural log of 1 is 0, because e to the 0 is 1. So this is f prime of 0 times 1. And we know that on the interval from -3 to 2, f prime is positive. So g prime of -1 is greater than 0. So g is increasing, in this case, at x equals -1. All right, so that's kind of a fun one, right? Well, just different ways to look at it. All right. Well, you knew Newton was hanging out, right? He's ready to come back. Let's welcome Isaac Newton back and do a little bit of velocity and particle motion. The function s of t equals t squared minus 7. I meant to make that a t. Minus 7t plus 10. Describe the motion of a particle along a line for t greater than 0. We're going to find the velocity function of the particle at any time t greater than 0. Okay, well, velocity is the derivative of position. Velocity is the rate of change of position. So v of t must be equal to 2t minus 7. Very good. All right, identify the time intervals in which the particle is moving forward and moving backward. Well, we'll be moving forward if the rate of change is positive, meaning if velocity is positive. So I'll just solve velocity equal to 0 so I can find where it's a 0. I get 7 over 2 equals t. Let's use a number line. 7 over 2. Now, remember, we're for a domain of 0 to infinity, so make sure we mark that domain. We don't want to use any negative time values in this problem, because in this problem, they're not allowed. Sometimes they are, but not in this problem. So if I plug in like a 1, I would get a negative number, and if I plug in something like a 4, I get a positive number. So we can see the particle is moving forward on 7/2 to infinity, because we could say v of t or s prime of t, but v of t is greater than 0 there, or then, right? And the particle is moving backwards on 0 to infinity. 0 to 7 over 2. Remember, don't go down the negative infinity because they said just for time greater than or equal to 0. Because this time v prime of t is less than 0. All right, the acceleration of a particle. The acceleration is the rate of change in velocity. So we take the derivative of velocity. So the acceleration is 2. So this particle is experiencing a constant acceleration. For what intervals of time is the velocity increasing and velocity decreasing? So when is velocity increasing and when is velocity decreasing? Well, I think we can see, since acceleration is constant, we're going to say velocity is increasing on the interval from 0 to infinity, because acceleration, which is v prime, we can use that, which is equal to v prime of t, is greater than 0 for that same interval, right? For what time intervals is the particle slowing down? Well, slowing down and speeding up, those do not take into account direction, okay? Velocity is always increasing, but it's not always meaning we're speeding up, because we would say our velocity is increasing if we're moving backwards at a slower and slower rate. Say I was moving backwards at 100 meters per second, and then 99 meters per second, and then 50 meters per second. I'm actually, what we would say, my velocity is increasing because I'm going negative a less amount. But my speed is slowing down. So it turns out that we know that we are slowing down or speeding up if acceleration and velocity are working together. In other words, if they have the same sign. So if acceleration and velocity have the same sign, we know we are speeding up. Okay? That means that we are increasing our velocity in the direction that we're going. So, and if acceleration and velocity have opposite signs, that means we're slowing down. So it asks, when are we slowing down? Well, we know that the acceleration is always positive. But if you recall, we found that velocity of t is less than 0 on 0 to 7 over 2. And since acceleration is always positive, that's when they're working against each other, right? So we're going to say we are slowing down on 0 to 7 over 2. Find the displacement of the particle from t equals 0 to 5. All right, well, let's find the displacement. The position function let me copy and paste that. Our position function was t squared minus 7t plus 10. So let's find s of 5. Well, s of 5 would be 25 minus 35. So 25 minus 35 is a negative 10 plus 10 is 0. Well, what is s of 0? S of 0 is just 10. So that tells me that the change in position is 10. From over the course from 0 to 5, we are in a different position. We are 10 units forward of where we started. And that's all it tells us. It doesn't tell us any kind of history. All right. Describe the behavior of the particle over the time from 0 to 5. Okay, well, I would say the particle moves backward while slowing down. Then moves forward while speeding up. That would be the behavior over that time. Okay, let's take a look at the next problem. It says use a graph of f prime to identify A, the intervals in which the graph of f is increasing and decreasing. Go ahead and why don't you pause the video and give this one a try. Okay, so let's take a look at practice 6.3. If you haven't started it yet, go ahead and try it, or you can do these first few problems and then pause it while you do this last one. All right, let's see how we did. The intervals on which the graph of f is increasing and decreasing. Justify. Well, this is the graph of f prime. So this here is f prime. The only way we ever say that a graph of f is increasing is to say that f prime is positive. And we can say that f is decreasing is f prime is negative. That's the only acceptable justification. So in this case, we should say that f is increasing on -3 to 2. And looks like 4 to 5. Might be 4 to infinity. I didn't include a domain restriction. These are just practice problems, right? And that is because f prime of x is positive. It's above the x-axis there. F is decreasing on -4 to -3. And again at 2, 4. Okay, so we said f was decreasing on -4 to -3 and 2 to 4. And that, of course, remember, we can only justify that by saying that f prime is negative. All right, the values of x at which the graph has a relative maximum or a relative minimum. Well, we know we have a relative max at x equals 2 because f prime changes from positive to negative at x equals 2. When we have relative mins at x equals -3 and x equals 4, because f prime changes from negative to positive there. The intervals on which the graph of f is concave up and concave down. Remember, concave up is defined to be the interval where f prime is increasing. So therefore, f is concave up on -4, if we kind of round it to the nearest integer, to -1, and positive 3 to 5. How do I know? Because f prime is increasing. When are we concave down? Well, f is concave down on -1 to 3 because f prime is decreasing. The value of x at which the graph has an inflection point. Well, the values for x having an inflection point are x equals -1 and positive 3 because that's where f prime changes from increasing to decreasing or decreasing to increasing. So x equals -1 and x equals 3 because f prime changes from increasing to decreasing or decreasing to increasing. All right, got another practice problem for you. I got a graph of f. I want you to put the following lists in order. Pause the video and give it a try. Okay, so this is a little unusual in that they're actually giving us a graph of f. Probably not going to happen too often, but it's just a good connection. So f prime of -2. Well, at -2, f prime is definitely a negative slope, right? That's a negative slope. And see, f prime of 1, well, that appears to be a slope of 0. And f prime of 0 is definitely a positive slope. So they're actually giving these in order. So this is f prime of -2 is less than f prime of 1, which is less than f prime of 0. What about f double prime of 3? Well, at 3, -3, I'm sorry. At 3, what is the graph doing? Well, we appear to be concave down on that region. So that's going to be a negative number. F prime of 0, we appear to be concave up there. So that's going to be a positive number. And we're told that -1 is rotates an inflection point. So that means f prime of -1 is either undefined or 0. But in this case, it's going to be 0. So f prime of -3 must be less than f prime, f double prime of -1. That's a typo. Which is less than f double prime of 0. Okay, let's try another one. The position of a particle traveling on the y-axis is represented by y of t equals sine 2t plus t for 0 less than or equal to t less than or equal to pi. Find the interval where the particle is traveling in a positive direction. That is, up. Pause the video, by the way, if you haven't yet already, and try this. All right, let's see. Now, y of t is the position, so we can find when we're traveling in a positive direction by getting the derivative, which would actually be velocity. So we can actually use that. V of t. We could also say vy, velocity in y direction of t. The derivative of sine is cosine u times u prime, so with the 2, plus the derivative of t is 1. We want to find when we're traveling in a positive direction, so let's solve this equal to 0. So we have 2 cosine 2t plus 1. So that's going to end up with a -1/2 is equal to the cosine of 2t. So I'm going to say that's going to happen. Let's see here. When do we equal -1/2 for cosine? Well, that's going to be when t is equal to 2 pi over 3 and 4 pi over 3. But that's 2t. So I have to divide those by 2, and I get pi over 3 and 2 pi over 3. Okay. Now we need to put that on a number line. And I may not have given us quite enough. May not have given us quite enough room, but that's okay. We can make it work. So pi over 3 and 2 pi over 3. And our interval is 0 to pi. Okay, so the velocity when we are in this region here, that is when let's see here. Let's think like pi over 6. If I multiply it by 2, I get pi over 3, which is a half times 2. That's a positive number plus 1. Okay, that's definitely positive. Then we come over here, and if we do something like pi over 2, that would be in this region, right? Pi over 2 times 2 is pi. The cosine of pi is a negative 1. Well, that's going to be a negative 2 plus 1. That's going to be negative. And then over here, it's going to become positive. So when are we moving up? On 0 to pi over 3 and 2 pi over 3 to pi. How do I know? Because v is positive. All right, I should probably write a complete sentence, but I'm running out of room. Find the intervals where the particle is traveling in a negative direction. Well, we basically already did that, right? That would be pi over 3 to 2 pi over 3. Because v of t is negative. Find the intervals where the particle is accelerating. Okay, so to find when it's accelerating, we need the acceleration function, which is the derivative of velocity. So that would be a negative 4 sine 2t, because the derivative of cosine 2t is negative sine 2t times 2, and I already had 2 on the outside, and then the 1 drops out now. Well, let's set this equal to 0 and solve this. So you can see that it's when the sine of 2t equals 0. Well, sine is equal to 0 at 0 and pi and 2 pi, which if I divide that by 2 gives me 0 and pi over 2 and pi. But I'm not going to include the endpoints of the interval. So we're just going to look at pi over 2. Because that's 0 and that's pi. And from 0 to pi over 2, that would be everything. Sine is going to be positive. You know, even if it's like pi over 3, that'd be 2 pi over 3. That'd be in quadrant 2 where sine is positive. But we're multiplying by a negative, so that's negative. But then after that, we're going to become positive. So the particle is accelerating, not necessarily speeding up. We've talked about that though, right? Is accelerating on pi over 2 to pi because a of t is greater than 0. What is the absolute maximum and minimum position of the particle on the interval from 0 to pi? Well, to do that, we need to evaluate the position at our critical numbers pi over 3 and 2 pi over 3 when the velocity equals 0. When velocity equals 0, if something's going up and then comes back down, its maximum height occurs when that velocity is 0, that stasis point. So we want to evaluate position, which is y of t. I think we were starting with y of t, right? Y of t is sine 2t plus t. And we're doing that over the interval from 0 to pi. And we did find that we had a critical number. We found that y prime pi over 3, I think, right? And 2 pi over 3 were both critical numbers. They equaled 0. All right, so let's just evaluate. Y of 0 is 0. Y of pi over 3 is equal to the sine of 2 pi over 3, which is the square root of 3 over 2, plus pi over 3. Y of 2 pi over 3 would be the sine of 4 pi over 3, which is a negative root 3 over 2, plus 2 pi over 3. And what is the y of pi? Well, y of pi would be 0 plus pi, which is pi. So the question is, which one of these is bigger? I know the minimum, by the candidates test. Y equals 0 is the absolute minimum. And what is the absolute max? Well, how does 3 pi over 2 plus pi over 3 compare to negative 3 pi over 2 plus 2 pi over 3? That's probably a more difficult judgment call than you can be expected to ask without a calculator on the test, but we could probably figure this out. Pi divided by 3 is, a little bit more than 1. So we've got a little bit more than 1 plus a number a little less than 1. So that's like about 2. 2 pi over 3 is a number a little bit more than 2 minus a number a little bit less than 1. So this number here is close to 1, and this number here is close to 2. So we're going to say that it's going to be the square root of 3 over 2 plus pi over 3. Again, don't worry about the arithmetic there. They're not that mean on the AP exam, but it's hard to make up these questions with easy numbers. So a calculator would be fine. Speaking of calculator, let's use a calculator to graph y prime and determine the x coordinates of any relative maximums. So I'm going to do that. I'm going to go to Desmos.com, and I'm going to graph that equation, and you should do so as well. So I'll graph y equals x cubed plus, minus 4x squared plus 1 over the square root of 2 plus x squared. And you need to know how to do this with any calculator because you can't use Desmos during the exam, but it sure is nice to present with. Well, we can find out. I see this y prime is crossing the x-axis at these points here. So these must be the values of relative extrema. We're looking for relative maximums, and that is clearly at 0.537. On the AP Calculus exam, you're supposed to use 3 decimals. So I'm going to say x equals and I've already forgotten, 0.537 locates a relative max because y prime changes from positive to negative there. Okay, practice 6.7. Given that f double prime is equal to x minus 3 squared times x plus 1 cubed, how many points of inflection does it have? Well, let's solve it equal to 0. All right, well, I think you can see that x equals 3 and x equals negative 1 would be the values, right? We'll put them on a number line and see if they change signs. So if I plug in a number like 0, I'd get well, this is always positive. So this is always positive. Don't even worry about that. If I plug in a 0, 0 plus 1 is positive. So that's positive. Plug in a number like 4, again, that's always positive because it's squared. 4 plus 1, that's positive. If I do a negative number like negative 2, that'd be negative, and negative times positive is negative. So x equals negative 1 is an inflection point because f double prime changes sign there. So what's the answer? 1. All right, practice 6.8. The table below shows the values of f of x, a twice differentiable function. Which of the following could be the graph of f prime over the interval from 0 to 5? For each graph, explain why or why not it could be f prime. Well, give it a try. Here's A, B, and then here's C and D down here. So if we look at graph A, all right, hopefully you pause and give it a chance. Let's take a look at the table. As you can see, f of x are positive values, so it can't be A, right? And also look at these f of x values. Oh, I'm sorry, this is not a graph of f. Sorry, we're looking at f prime here. These are f prime. Sorry, I was saying, surely that's not it. Okay, so what we see though is that these values are decreasing, right? So this is a possibility. So I'm going to put a star next to this because definitely it's increasing. Well, what about B? Well, this is a possibility as well because f is decreasing. Let's look at the other choices. Okay, this is a possibility because, again, like we said, f was decreasing, right? And this is a possibility because, no, it's not a possibility. That can't be true, right? All right, let's take a look at the next part of this. Well, if we look at this, we can see that y is decreasing at a decreasing rate, right? So we need f prime to, if it's decreasing at a decreasing rate, doesn't that mean that it's actually that f prime is increasing, right? So we can see that the decrease here is -6, -2, -2 again, and then -1. So what we're seeing is the rate of change is getting smaller. So we need f prime to be increasing. F prime is negative and increasing. And I think that's the only one that does that is B. Right, note that this would be a concave up graph. All right, last one. What is the maximum value obtained on the interval from -2 to 4 by this equation? Okay, do you remember that determining an absolute max or absolute min, when we say maximum on a closed interval, that's what we mean, that you should use the candidates test. So we'll do y prime is equal to 3x squared minus 5x minus 8. And we'll find the zeros. I think this will factor most likely, I hope. If not, we're going to be in for a world of hurt. Let's see here. 3 times 2 is 6. Let's do 8 and 1. So we'll do a -8x and a plus 3x. Makes -5x. Okay. So we can, I'll write it like this. Y prime of 8 over 3, when you solve that equal to 0, is equal to y prime of -1, which is also equal to 0. So let's evaluate at each of the endpoints. -2 would be, let's see here, -8 times 4 divided by 2 is 2, times 5 is 10, and then plus 16. So that's a -12. Check my arithmetic for me, but I'm going to just hope that that's right. I'm going to do -1 next. Bypass the 8/3 for a second. So -1 would be, let's see here, -1, and then it's going to be a -5/2, and then a plus 8. So that is 7 minus 5/2. So that's 14 over 2 minus 5 over 2 is 9 over 2. And I'll do the 4 next. We got 64 minus 40 minus 32. That's 24 minus 32 is a -12 as well. And I think that's right, right? 24 minus 32. Oh, wait. No. No. That is not right. -8. It didn't feel right. And I felt like maybe I made a mistake. And let's do y of 8/3. I think we have avoided this long enough. 8/3 cubed minus 5 over 2 times 8/3 squared minus 8 times 8/3. And I'm going to just use a calculator. So let's just let a calculator do the work for us, and that's okay, right? That's okay. We don't have to tell anybody. So 8/3 cubed minus 5/2 times 8/3 squared minus 8 times 8/3. -20.14. All right, so do we have an absolute max? I think we have a winner at 9 over 2. And so we have an absolute max of 9 over 2 and an absolute min of -20.14, and this is by the candidates test. All right, well, that's all she wrote for this lesson. I'll see you in the next one.